planet Earth. While we think we know it all, this collection features facts that make Ridley Scott's star engineers look like kids in a sandbox. Let's get started. In the biochemical processes of life on Earth, an unjustifiably important role is played by a chemical element that is extremely scarce on our planet, almost non-existent. That element is molybdenum. The most likely explanation for this phenomenon is that life originally arose in another world, on another planet, where there was much more molybdenum than on Earth, and where its role, which is unjustifiably important under the conditions of our planet, was more justified. In addition to this, the American scientist Schroeder, as a result of many years of research, discovered a whole range of chemical elements that are also extremely scarce on Earth, but even a comparatively large amount of them. An increase in the dose of which in the soil not only does not harm plants, as is usually the case, but even extends their lifespan. These elements include nickel, manganese, chromium, vanadium, and molybdenum. It should also be added that the human body contains a wide variety of chemical substances, representing almost the entire periodic table. However, only 14 of them have been recognized as essential, among which are the previously mentioned nickel, manganese, chromium, vanadium, and molybdenum, as well as cobalt, selenium, and fluorine. Such a discrepancy between the chemical composition of our planet and the completely different percentage distribution and set of elements necessary for the existence of life forms on it seems inexplicable. If we accept that all earthly life has an extraterrestrial origin, everything makes sense. Some terrestrial plants absorb the maximum energy from the sun in a different part of the spectrum than this star emits. They behave as if they had undergone an evolutionary path of development on the planets of another star, whose radiation maximum is shifted toward higher frequencies, which corresponds, for example, to Sirius. According to these graphs, the homeland of terrestrial plants should be located near a star that, on the Hertzsprung-Russell scale, belongs to the class of white bright subdwarfs, while the Sun belongs to the class of yellow stars. This may indicate that certain types of plants and animals were adapted to the conditions of Earth's climatic zones from other planets. Certain food crops, such as maize, lack wild ancestors and can't reproduce or grow wild on their own. They require intelligent beings for reproduction. Myths say that long ago, beings from the sky, seen as gods by people on Earth, gave them this grain. This is what George Wells Biddle, an American geneticist and Nobel Prize winner in physiology and medicine, said. In 1958, corn had a strange genetic cocktail mixed in, and it is impossible to find the exact ancestor of this plant on planet Earth. It's also very strange with wheat. The Russian scientist Nikolai Vavilov, as a result of a global study of various types of wheat, identified as many as 3 independent places of origin for this crop. Syria and Palestine turned out to be the homeland of wild wheat and einkorn wheat. Abyssinia, or Ethiopia, is the homeland of durum wheat, and the foothills of the Himalayas are the center of origin for soft wheat varieties. As Vavilov wrote in his work, a few remarks on the problem of the origin of wheat. It is quite significant that in Abyssinia, where the greatest primary varietal diversity of the 28 chromosome cultivated wheats is found, all the main wild relatives of wheat are completely absent. This fact makes it necessary to revise our understanding of the process of origin of cultivated plants. At the same time, the differences between wheat species are enormous. Einkorn wheat has 14 chromosomes. Wild and durum wheat have 28 chromosomes, while soft wheats have 42 chromosomes. Doubling and tripling the chromosome set requires methods and techniques that are incompatible with primitive selection, up to and including intervention at the genetic level. At the same time, even the earliest archaeological finds already reveal a ready-made diversity of wheat species. A similar separation between cultivated species and regions of their wild forms is seen in many plants, including barley, peas, chickpeas, flax, and carrots. In no ancient myths or legends known to people does anyone try to credit themselves or their ancestors with the development of agriculture. This is always certain gods' prerogative. In Mexico, the great god Quetzalcoatl brought corn. Viracocha taught agriculture in the Peruvian Andes, while Osiris introduced it to Ethiopia, Abyssinia, and Egypt. The Sumerians were introduced to agriculture. Enki and Enlil, gods who descended from the heavens and brought them wheat and barley seeds, helped the Chinese master agriculture. Heavenly geniuses. And in Tibet, the Lords of Wisdom brought fruits and grains that were previously unknown on Earth. According to the oldest legends and traditions that have come down to us, the gods looked and behaved much like ordinary people, but their abilities and powers were incomparably greater than those of humans. The planet's oldest peoples never saw themselves as originating from Earth. They either trace their lineage from celestial gods or have myths about their ancestors directly migrating from other worlds. This ancient idea even influenced the biblical myth of the first humans' expulsion from paradise and their banishment to Earth. By then, life had already taken root here as animals and plants. In ancient texts, there is information that was clearly brought to the planet Izvik. Clay tablets found in the temple libraries of Nippur and Sepur indicate that as far back as 5,000 years ago, it was known in Sumer that the starry sky makes a complete revolution. The Earth's axis precession period is 25,920 years occurring on the opposite side of the globe. The same number appears in the astronomical texts of the ancient Maya. How could ancient peoples have had such precise knowledge about the period of precession? After all, the entire history of modern humanity is less than half the length of this cycle. The concept of the true year was not only known to the ancient Maya, but they also knew its exact duration. They considered it to be 365,242,199 ten-thousandths of a day. According to the Gregorian calendar, which we use today, the duration of the true year is 365 and 2,425 thousandths of a day. And only in recent decades, with the help of the most precise astronomical instruments, its actual duration was determined to be 365 and 242,198 millionths of a day. Such extreme precision is simply impossible with the gradual development of civilization on the planet. Science has no answer. How did ancient Egyptian priests accurately understand the planet's magnetic poles? On the other side of the planet, ancient Indian sources estimated the age of the Earth at 4.32 billion years, which is close to modern data. And the cuneiform tablets of Mesopotamia, compiled more than 3,000 years ago, claim that the radius of the Earth is 6,310.5 kilometers. It was only in our time that it was calculated to be 6,371 kilometers. 20th century scientists attribute this slight difference to Earth's expansion. The ancient Sanskrit texts Surya Siddhanta and Brihad Sataka divide the day into 60 parts. Kala were equal to our 24 minutes and, in turn, were divided into 60 Vikala. Further sexagesimal division of time intervals into Para, Tatpara, Vita Tatpara, and Yima ended with the unit Kashta, which was equal to 1/300,000,000th of a second. Why would a backward people need such a unit of time, which could only be used in atomic physics? In ancient times, each civilization had its own calendar system, which started from some real event, a flood, an earthquake, or the end of a people's migration. In the ancient history of humanity, there really is an amazing coincidence in the starting points of different calendars. The ancient Egyptian calendar cycle, the Sothic period, lasted 1,460 years. One of these cycles ended in the year 1322 before Christ. If you count 7 cycles back from that year, you get 11,542 before Christ. The ancient Assyrian calendar consisted of lunar cycles of 1,805 years. The end of one of these cycles falls in 712 before Christ. If you count back 6 cycles from it, you get 11,542 before Christ again. In ancient times, the ancient Indian lunisolar cycle consisted of 2,850 years. The Iron Age, Kali Yuga, which we live in now, started in 3102 before Christ. Counting 3 cycles back from this date, we get 11,652 before Christ. For the ancient Maya in Central America, the beginning of the calendar era falls on 3,373 before Christ, and the calendar cycle lasts 2,760 years. By counting back 3 cycles again, we arrive at 11,653 before Christ. Such similar calendars among distant peoples, separated by oceans and deserts, can't be explained by chance. It is obvious that some single event of global significance served as the starting point for all 4 calendars. Less well-known, but recorded in ancient India and Mesopotamia, in Africa and ancient Greece, in Central America and Tierra del Fuego, is the myth that before the flood, there was no moon in the sky. For example, the Bushmen of South Africa have an ancient legend that the moon appeared in the sky only after the flood. A similar legend is told by the Indians of Tierra del Fuego. One day, the sea rose up to the sky, and the moon emerged from it. The Greek epic about the semi-legendary happy land of Arcadia calls its inhabitants Proselines, or Prelunarians, because they lived on Earth when there was no moon in the sky yet. This myth was also confirmed by Apollonius of Rhodes, the keeper of the Library of Alexandria. Referring to manuscripts known to him, Apollonius wrote that the moon did not always shine in the sky above the Earth. And during excavations in Sumer, clay tablets were even discovered that tell about events after the flood, when the moon appeared in the sky. There are also many oddities about Earth's position in the solar system, but we'll discuss that in another episode. Well, how interesting! Give us your feedback, rate this video, and leave a comment. There's still much more to discuss on this topic. Whether we create more episodes depends on your feedback, so send your requests and see you next time.